I'm going to talk about AI, talk about a lot more than that as well. And mostly I'm going to be sharing a bit of the thinking around the design and architecture of Circuity. Before I jump into the nitty-gritty of the talk, let's just start by answering the question, what is Circuity? And maybe more importantly, why do we think that KiCon attendees and KiCad aficionados might care about that? So Circuity is a KiCad compatible Git and web browser native EDA tool. As a longtime KiCad user and a software guy, I started Circuity to be the KiCad companion that would let me work with the type of browser and Git-based workflows that I'd come to love from my software development career. In talking to a bunch of my hardware professional buddies, the ideas seemed to resonate with them too, and Circuity was born. So whether these workflows and Circuity's approach resonates with you as well or not, my hope is that you'll find some of the ideas in this talk interesting and maybe food for thought when it comes to your own EDA workflows. So real quick, what do I mean when I say browser and Git-based workflows? So for software, I really love an asynchronous workflow, the flexibility of working with a distributed version control system like Git. I get like a source of truth stored in GitHub or GitLab that I can go to for past revisions, to track experimental changes, and to keep me in track of changes I make in response to the occasional defect in my work. But I really want to work with files, but I also really want to have the convenience of sitting in front of any browser with nothing to install and have access to all my data within a few seconds. So I'm going to talk through a bunch of product and design decisions and our technical approach, more about our Git support in a minute, but before I get to that, I want to quickly level set on the rest of the big picture of Circuity. So Circuity is more than just a cloud drive for KiCad files with Git. It's a full-blown editor of KiCad files, including schematics, sheets, symbol libraries, symbols. Circuity presents, you can see here, a tab-based interface with a stack of panels on each side, floating toolbars, modals, sort of the UI paradigms we've come to expect from both KiCad and browser-based software. Circuity also supports boards, footprint libraries, and footprint editing. We aim to be a companion to using the KiCad native app, but also to support end-to-end EDA tool functionality, including generating files for manufacturing. There will probably, scratch that, definitely always be things that KiCad can do that Circuity cannot do. Today, that list of things that Circuity does not even try to do yet is long and includes things like 3D preview, simulation. Over the time, we're closing that gap. But despite that, as we heard from Wayne yesterday, KiCad development velocity is absolutely insane. So Circuity will always be chasing new features, like even not stuff in 10, but some stuff in 9, like multi-channel design support that's not yet in Circuity. As a companion to KiCad rather than an outright replacement, we think that's okay, as long as we do no harm to the KiCad files being edited in Circuity. We think gaps and features are okay. Open it in KiCad. So in addition to native version control and collaboration features, we think there are opportunities for Circuity to introduce other sort of more web-native features, and this is the kind of stuff that Seth was just talking about. A good example of this is Circuity's Research Assistant. So I'm going to talk a bunch more about our Research Assistant a bit later in the behind the scenes in the talk, but for now, know that the Research Assistant is a opt-in assistant on a per workspace basis, and it is opt-in based on the owner of the workspace. It prioritizes privacy and intellectual property of yours, not ours. We don't train on user data or user actions, and we only work with model providers that have the same priorities as us. Okay, so now I think we have a pretty good level set on what Circuity is. I'm going to go real quick and just give you some background on me. I'm a software developer by trade, spent the first half of my career in console video games, so that my era is like Super Nintendo through PlayStation 3. I founded and ran 2 independent game studios, the latter of which was acquired by Sega, where I became the North American CTO. The through line of my career has really been building companies focused on building visual editors. So a little bit later, I co-founded a visual behavior development platform that was ultimately acquired by Twitter, where I ended up being the VP of engineering through the IPO. More recently, I co-founded a data-focused presentation company that was acquired by Medium.com. But software aside, I've always been passionate about electronics. My era of console game development was all about bit banging on the hardware with no OS, and I suppose that ultimately Forrest Mims III is probably to blame for my inspiration, and it's just never really left my blood. My love for electronics goes from building, I kind of like the smaller stuff, no surprise, game type things. This is a little Bluetooth and Wi-Fi enabled. It's an NRF, I think it's a 5240, little flash RAM, little LiPo battery health, little networked OLED screen. But more than just building stuff, it's also led me to many maybe ill-advised expenditures, pilgrimages to Shenzhen to go do some factory tourism. I'm a little bit chagrined to say I should probably have just gone down the road because I'm in the Bay Area, and so I am going to be visiting Sierra Circuits a little bit later, take the tour that I've been promised, right? Yes, okay, great. Cool, so now that you know what Circuity is and who I am, here's what I've got prepared for us to talk about in the rest of our time together. So first off, let's talk about KiCad compatibility. So one of the first key design decisions we made for Circuity is that we would operate directly on KiCad data. No lossy import or export processes. So from schematics to boards, but also projects to themes, from symbol libraries to footprint libraries, Circuity operates directly on KiCad data. So we've developed a KiCad-centric collaborative data model, and the way it works is it represents a superset of the released KiCad version data. We've also developed a set of KiCad file format parsers that read KiCad files into our data model. We remember the original file's version so that we can both save edits back to the correct KiCad file version, but also so when we're editing, we know to constrain the editor to what that version of KiCad supports. I'm sure we're all familiar with kind of like the Christmas morning feeling of booting up a new version of KiCad, and you open kind of an old file and it upgrades it and says, hey, when you save it, it's going to save it to the new version. And that is awesome and the right way to do a native app. We do not have that luxury. So if we open your KiCad 7 file or your KiCad 6 file, we will save it as your KiCad 7 or 6 file. But more than just file formats, Circuity works with KiCad concepts. We know that most of us have heard about talks, and I think most of us have used many different EDA tools. And so there's a lot of ubiquitous concepts, symbols, pins, wires, net lists. But there are many concepts that are more KiCad specific, specific KiCad flavor. The relationship between sheets and sheet instances and reference paths. And we had a great talk about custom design rules. This stuff has maybe got some analogies in other packages, but KiCad has a flavor that I think most of us in the room and probably listening on the webcast have come to love. So Circuity does not just understand KiCad file formats, but it also understands KiCad design paradigms. Support for KiCad versions does not end with schematics and boards. We also load the correct version of KiCad's global symbol and footprint libraries based on the schematic or board being edited. So whichever tab is current, whatever schematic or board or footprint or symbol you're editing, the Workspaces panel on the side will show you the appropriate KiCad 6, 7, 8, or 9 global libraries and shows you whatever your project libraries are for that file you're editing. Okay, but beyond just file formats and data models, we've put a ton of work into making Circuity's renderer performant and look like KiCad, down to the pixel level. Several of us on the team have got a background in computer graphics. For me, I've kind of already talked about that. It's PS3 era games development, making level editors for open world games. Give me 1 second here. For one of my teammates, Joe, that's several years spent with the Blender Foundation, working on features including early support for subdivision surface rendering and editing. And we all know from using it, KiCad is no slouch when it comes to rendering performance, especially for those of us who remember before the hardware acceleration. It's been amazing. And we can load really complex boards like we were seeing the CERN board in KiCad and be performant. So we've spent a tremendous amount of time to allow Circuity to keep up with that same kind of 60 frames per second rendering, but in the browser. So really that means things like TypeScript, C++ and WebAssembly, web workers, which allow us to use hardware cores, hardware threads, WebGL. This is just a little blurb about an algorithm we actually don't use anymore, which is a stencil and cover style algorithm, but we have a new vector-based algorithm that is more generalized and even faster for us. Okay, but just moving on, I want to kind of touch on a couple different other areas of Circuity, give you some behind the scenes about how things work and how we think about it. And it's not lost on me that I'm talking to a room of mostly hardware developers, but I am going to talk some software stuff because I love it. I'll try to go quick. But one of the questions that I get a lot is like, okay, so did y'all just port KiCad to like JavaScript and stuff? Like, isn't that the sane way to do it? And the answer is no, most definitely not. Actually, unfortunately, because I have a really high regard for the KiCad codebase. But Circuity is implemented from scratch in about 750,000 lines of TypeScript and C++, along with a couple hundred NPM packages. We have plans to open source significant portions of our codebase. Many members of our team, including myself, have spent time doing just that at large organizations like Twitter, Blender Foundation, Sega. And that's given us a healthy respect for the effort involved in doing a good job open sourcing something. So we want to make sure we do a good job with that. But we are committed to that. One of the early lessons I learned in video games is you don't just build the game and then like add multiplayer at the last minute. And similarly, with something like Circuity, we have to design and architect the multiplayer in at the beginning, and so that's what we've done, and that's a big part of why we just can't port source code. It's also GPL, and we're not GPL, so that's another reason that we don't look at or use the KiCad source code for Circuity's purposes. So like most all cloud software, and this part I'll try to go quick, but maybe Rose will nudge me because I love this stuff. But Circuity's implementation is split into two parts. It's got the browser-based side and the back-end side. In our case, the browser-based side, we're looking at Chrome, Firefox, anything kind of WebKit-based. And on the back end, that's AWS for us. Our web app communicates with the back end over a mix of HTTP2 and WebSockets, and it travels through a set of Amazon-hosted content delivery networks and load balancers to get to the Circuity services. This also allows us to use best-in-class security. All the Circuity services stuff is off the internet behind all this Amazon front-end tech. We make pretty heavy use of distributed queues to help us coordinate things inside the Circuity services, and ultimately we're storing stuff in databases and storage managed by Amazon. That gives us 4 nines resilience and crazy backups and multi-region stuff. It's pretty awesome. Last thing I want to mention about this architecture that's maybe not obvious, that's kind of cool, because our services are done in Kubernetes, because we're using pretty modern and typical cloud techniques, we actually can stand up an entire Circuity cluster on our own local development environments. But also it means that it's not very hard for us to allow Circuity to be deployed in a standalone, somebody else's AWS account, or maybe completely closed on their own hardware somewhere for the security or paranoid-minded, or both. So last little bit of back-end stuff, I promise, but we're a service-oriented architecture, so zooming in on that Circuity services part, what we are is a set of Docker containers written in TypeScript mostly, orchestrated by Kubernetes. So Kubernetes kind of orchestrates all these pods or services. We're somewhere between a monolith, single app, and microservices. We have only maybe a dozen or so different services, which we run multiple copies of each for resilience and based on load. So examples include the user service, which handles usernames and passwords, notification service for delivering emails, Slack messages, in-app notifications. The workspace service handles permissions and sharing. Document service, near and dear to my heart, is where the heart of our collaborative data model is. Render service is pretty fun. That one handles rendering everything from previews, thumbnails, PDFs, but also Gerbers. And then the Git service deserves a bit of a deeper dive. So I'm actually going to jump into that now. So combining Git workflows and browser-based editing, I mentioned that at the front, that's kind of the raison d'etre of starting Circuity. Sorry, Lucy, if she's here, but my French sucks. We designed Circuity to allow multiple users to collaborate on collections of KiCad projects asynchronously, meaning that they can all submit sets of changes and commits to services like GitHub or GitLab on their own time. So more than just a way to collaborate, this also ensures that users are in control of their own data. It's fundamentally KiCad files on Git. As many of you may know, Git workflows are not just about collaborating with others. The way I like to think about it, they're also for collaborating with past and future you. helping you manage design revisions, experimental branches, keep track of bug fixes, board revisions as you spin different revs. So I think, in some cases people may think, I'm not collaborating with anybody. Yeah, you got past you and future you. Those are pretty tough collaborators, at least in my case. It's hard to collaborate with future me. But despite being a browser-based app, we present a file-based interface to users. So in Circuity, users create what we call workspaces. That's our unit of thing, atomic unit. And a workspace contains a set of files like KiCad projects, schematics, boards, PDFs, markdown files, firmware files, whatever it is you're throwing into your Git repo. And on that point, Circuity, every workspace in Circuity contains its own Git repository. So this is a Git repository hosted by Circuity. In Circuity's asynchronous collaboration model, our vision of it is that every user creates their own workspace with their own clone of the upstream Git remote repository, which may be in GitHub or GitLab or maybe their corporate Git repository. So users edit the files in their own workspaces, commit their changes to their own workspaces, and then they can fetch updates made by their collaborators from GitHub or GitLab and use our side-by-side views so they can do comparisons, copy and paste between the two, resolve differences and conflicts. I was really excited to see that KiCad 10 has visual differences on the books. We also have a visual differences feature that is in progress. And so ultimately, all ways to figure out how do I merge conflicts with collaborators, whether they be humans or past and present, future you. Ultimately then pushing all these changes back up to the source of truth at GitHub or GitLab. So if our weird little startup goes away, all your stuff's KiCad in GitHub or GitLab. Back to the software stuff briefly. On the face of it, Git may seem like a pretty solved problem. It's open source. There's a very robust C++ library called libgit that's the canonical Git implementation used by the Git CLI. However, while Git was architected by Linus for managing kernel patches for Linux, to store those in the cloud and trade them, Git clients were architected to do everything on a user's local hard drive. So due to this, it doesn't really work in the cloud to actually run Git operations on the back end. So we decided, because we're masochists, that we would implement a cloud-based version of Git from scratch in TypeScript, including the Git protocol implementation. We drew a lot of inspiration from GitLab's Gitly, which is a sharded essentially Git service in the cloud. In very brief, we have our own thing called a Git archive. If you know about Git stuff, it's essentially like a Git pack file, and we have kind of cached partial Git archives with indexes on each Git shard in our Kubernetes cluster, and they can kind of stream back and forth to the source of truth storage in our servers. But of course, as I mentioned before, you're pushing and pulling to sources of truth like GitHub, GitLab, or corporate Git repositories. Okay, so while asynchronous collaboration with Git workflows, that was the founding thing I really wanted, it's not the only way that Circuity users can collaborate with each other. So we also enable synchronous collaboration. So if our Git workflows are about being asynchronous, about doing things on your own time, in your own space, without anybody watching you. Our synchronous real-time collaboration is about doing things with others, in front of others, in real time. So this is basically like Google Docs. The way we think about this is, while we want to spend most of our efforts designing at our own pace in a safe space, at our without having anybody second guessing us, we do occasionally want to invite other people into our space to pair with us in real time, and that's what our asynchronous collaboration does. Another key early decision that we made was to use conflict-free replicated data types as the basis of the collaboration in Circuity. I'll go quick because, again, I recognize this is not a software group necessarily, but I love this stuff. In past startups, I've done a more traditional operational transform-based approach, which is basically what Google Docs is based on. And recently, CRDTs have gained a lot of traction for a number of reasons. I'll just go super high level about it, but updates can be made from collaborators in any order. They're idempotent. You can apply them more than once. More importantly, they do not require a centralized server. So updates can be sent peer-to-peer, which is great for latency reasons, but also really great for this is that we have the potential for easy offline mode, where we're storing all these CRDT updates in browser local storage while you're offline, and then when you come back online, we do all these changes get applied. So the other big advantage of using CRDTs is something that I think we heard a little bit about before lunch, just this idea of like what is hot, what is getting the attention, what's getting the effort put into it. We were hearing, I think, a little bit about how Altium feels like maybe it's falling off, hard to say, but with CRDTs, they are definitely hot. That is the thing that everybody's putting effort into. And so in specific, we use something called YJS, which is a really great project. It's very JSON-based. So what we do is a real-time synchronization between our custom data model, which is sort of the in-RAM version of, as I mentioned before, a superset of all the released KiCad versions. We synchronize that essentially in a JSON-y format with YJS conducive to CRDTs, and then that gets synchronized across into other clients, goes from their YJS into their Circuity data model, and that's how we get the, you drag it, I see it kind of stuff. And then all that stuff, as well as being transmitted between clients, it's also going to cloud storage. So one thing of note before I move off of real-time collaboration is CRDT or operational transforms, whatever you pick, they're really great foundations. But one of the ways academics measure the quality of a collaborative algorithm is something called intentionality. And I think it's a really important thing to mention and something we've paid a lot of attention to. So the easiest way to think about this, in my opinion, is like if you have multiple collaborators working on a sentence in a Google Doc, you expect that that's going to be eventually consistent. Whatever the latency is and people's computer speeds and what's going on, you expect when everybody's done typing, eventually, they'll all have the same sentence. So intentionality is, yeah, but does that sentence make any sense? Like, is that sentence just a scrambled garble of letters? And we all see the same sentence, but it has nothing to do with what we were all typing. That would be poor intentionality. So there's a great potential for a visual application to have poor intentionality. For example, in the context of Circuity, what does it mean for two collaborators to attempt to drag the same set of connected symbols or footprints? Like, do we average the two? Does somebody win? What? And what about all the wires? So basically what we do in brief is something we call dynamic locking. When I grab and select something and start moving it, it'll show up as semi-transparent on somebody else's collaborator. They cannot themselves then select it. So it's a way for me to see like, oh, okay, you're messing with that. I probably shouldn't be. Lastly, our synchronous collaboration supports annotating schematics and boards with comments. We have a pretty robust comment system, allows Circuity users to chat with each other, and if enabled, the research assistant, which I will talk about in a second. So there's threading, reactions, emojis, and this idea of resolving comments, both in-app notifications, but also email notifications, which is kind of important because if you have somebody you've sent your design to with just a URL, and they maybe are or are not a KiCad user, and maybe they're lightly engaged with you because you're begging them for help, they can just get that email, click the link, open it up, reply to comments, and if you comment back, what are the chances they're going to open it again? Probably nil without, like Google Docs, getting an email back saying, Jeremy asked a follow-up question. So this is not new stuff. This is kind of tried and true design from many collaborative apps, whether it be something like Notion or Airtable or Google Docs, but we've got it. Okay, so on to what Seth was alluding to. Circuity does, in fact, have AI. So as I mentioned before, there's these opportunities because we are a web native app to do these sort of more web native features. Not that you can't add AI to a native tool, but our research assistant is a good example of that. Now, I spent a lot of time working in AI-adjacent fields. At Twitter, I was responsible for the search and relevance group. I did not directly manage it, but as a VP of engineering, it was in my span of control. And so I believe I'm pretty up on it and that it's very fraught with pitfalls, that AI can be a mess. But I also believe it could be super helpful if you do it right. So the thing I mentioned before, and before I go any further, is Circuity's AI features are all opt-in. So you have to choose to turn on the AI. Not as just a user of Circuity by itself, but on a workspace by workspace basis. So the owner of the workspace has to opt in for AI to be on for that workspace. And this is, again, because we take privacy and intellectual property super duper seriously. Okay, so when enabled for a workspace, Circuity's Research Assistant shows up on a sidebar on the right, and it has essentially an electrical engineering focused agent that has access to the data in your workspace, which includes schematics, boards, data sheets. So what we have sort of a two-pronged strategy on AI for Circuity. One is a research assistant, and the other one, which is not something we've released at all yet, or even to our design partners, is a co-pilot. And the way I would distinguish between those is the research assistant puts information at your fingertips at the time you desire to use the way you see fit. A co-pilot is maybe something you ask to help you do tasks. So our initial part of our strategy, the only thing that we are launching today, is the research assistant. So we've designed it to help provide input into design decisions and analyze work in progress. It will come as no surprise that the research assistant is large language model based. And as I mentioned before, I've been pretty involved in this space for a bit, and I've been tracking the rise of LLMs, and I'm not gonna lie, I've thought it was mostly not helpful for quite some time. I've been tracking it since 2012, which is the AlexNet paper, for those of you who are machine learning nerds, which is the convolutional neural network paper that kind of kicked off a lot of this idea of like, AI doesn't seem to work very well. What if we just threw all the data at it? And then magically it started to work really well, which was kind of shocking to everybody. Anyway, long story short, fast forward to, I would say, fall of last year, and some stuff really started to change, which is the size of the models and then the size of the context window. So I'm gonna go really quick here, but long story short on this, if we think of tokens as words, the context window is how much information you can dynamically give to the model. It has all this human knowledge baked into it, but without retraining it, without feeding it private data to bake into its model, how much kind of is the query? How much can you tell it? How much can you ask it? So we use a CAG-based architecture, cache augmented generation architecture. And what's interesting about this is that the context windows have gone from, call it early last year, maybe 1,000, 2,000 words, to now 2 million word context window, which means that we can feed this thing not just paragraphs of a data sheet, but we can feed it the whole data sheet. We can feed it not just fragments of a schematic and board, we can feed it all of it and still feed it War and Peace and have room left for it to think. So this is like game changing for a lot of AI tools, and it's why if you use things like Perplexity or some of these other research type tools, they've taken a massive jump. So if you were kind of, as most of us are technologists, keeping a pulse on things, if you were kind of keeping a pulse but took a little nap starting in September of last year, I would wake up and watch some YouTube videos and play around with some of this stuff because it just got crazy. So we've come along at the right time to benefit from some of that. So you can ask questions like, what does this circuit even do? And get bananas reasonable answers. It's still AI, still gonna hallucinate sometimes, but it's pretty interesting. And then baked into a tool like Circuity, you get a lot of hyperlinked context and all kinds of fun stuff. I could talk on and on about it, and if you want to, come find me afterwards. Okay, so maybe wrapping up a little bit. This is a pretty big day for us. At Circuity, we've been working on this for 2 years. We have a number of design partners we've been working with, but this has not been available. And as of now, we're making it generally available. We're launching it for the first time. It's an early look release. I'm mortified. I'm embarrassed. It's got bugs. It doesn't do things I think it needs to do. But what do they say? I think it's if you're not embarrassed, you're not launching soon enough. I'm embarrassed. We're launching soon enough, I think. Now, despite that, we do take your time very seriously, all of our users' time seriously, and we're committed to being responsive when it comes to bug fixes improvements. We would not be putting it out there if we didn't think that there would be some value to folks. But it is, you'll have to be a little gentle. And as I mentioned, ultimately everything's in KiCad format, and if there's something Circuity can't do, you can always open it in KiCad. So just sort of a little bit of nitty-gritty. This is really my love letter to the KiCad community, Circuity as a whole. And this is what we're doing for early adopters, which is open source, always gonna be free if you're doing open source hardware. No private projects though. no private workspaces. On the commercial side, and you can do commercial things with the open source plan. This is a subscription-based model, obviously. The starter plan, no Git, so makes me sad, but that's the starter plan. Free, lifetime free. What does that mean? It means if you sign up, we're never going to charge you. Now, when we get simulation or when we do other further future features, they may not be available in the plan that you have lifetime free, so you may need to upgrade. But if you like what's happening, and we value our early adopters, so we're going to try really hard to give you all the juice we can, as long as it doesn't break the Amazon bank. No Git workflows. Professional, $9 a month, 15-day free trial, and that one does have Git workflows. So we would love to get you to sign up. Tell us where we're full of shit. Tell us where things are not working. Tell us what doesn't happen. Tell us what you think we should have. Tell us what you like. That'd be awesome too. If you do sign up, we have a bunch of Circuity hoodies. Anybody, first come, first serve, but anybody signing up gets a free Circuity hoodie. So just come by and let us know that you signed up. Hit up Rose Wave. So this is Rose. And yeah, that's, oh, I should mention also, we have a student plan. We were actually in 5 universities in the fall, which was fascinating. I wasn't sure how we should market to students, and Mark Suster, our very lovely and helpful board member and investor, he said, don't figure it out. Give them a budget, tell them like no spray paint or vandalism, and turn them loose. And it was freaking awesome. So that was really great. So we do have a student plan as well. No commercial stuff for that. Anyway, that's my time. Thank you so much.
First off, thank you. I admit at first I was like, okay, how is this really different? But that was really interesting. As a fellow software person, I want to just give you a shout out that I did understand what you're talking about. That paper actually came up in my master's degree a couple years ago, so it is hot stuff. Question I had about the AI thing. I'm trying to remember the word, but we use AI a little bit where I work, but they had to pick a very specific model that was trained on very specific data for legal reasons. Can you speak to, like, first off, is your model something like built in-house? Are you using someone else's model? And where did you train data from? Do we have to worry about, you know?
Yeah, great question. So we definitely do not do that in-house. We are using OpenAI currently and Gemini, so we're switching between models. That's kind of the new approach, is to allow users to kind of pick which fundamental model is used. We are not training a model. We are also not fine-tuning a model. Both of those things are actually pretty out of scope for a startup like us. We are venture-backed, but we're tiny. We have 9 people, 4 engineers. So we are using the GPT-4o model right now. It's a reasoning model, which basically means like there's a feedback loop in it, and you kind of just ask the AI like, but why? And then it answers, and you say, but why? And it just keeps looping until it reasons itself into something interesting. So the magic for us is the instructions we provided and the context we provided. It is kind of amazing these models have got all human knowledge. So there is a fair amount of inbuilt stuff. We'll see in the future, but we're getting pretty amazing results out of that type of approach. So that's you do not have to worry about where it was trained from beyond what Google and OpenAI are training on, which is all human knowledge.
I'm curious, what does Circuity look like in 10 years when you've been wildly successful? And what is the relationship with KiCad at that point?
Great question. One of the ways I think about Circuity, and this probably goes to my game developer background, is I think about it kind of like a electronics CAD game engine. And Circuity with KiCad is our first game. And we hope it's a hit game, and we hope everybody loves it. But we're interested in making more games on the same game engine. So as I look forward into the future, I really found Seth's talk at the opening inspiring, this idea of why KiCad's important, why it needs to live, and why it shouldn't be seen as a threat. And all those things resonated for me. And that's a big reason why I wanted to do this, pick KiCad first, and why I've used KiCad. So I hope that Circuity's relationship with KiCad, whether it be sponsoring conferences, sponsoring development, contributing to the code base, I hope that we can have a great relationship going forward long into the future. But I also think there's an opportunity for Circuity to have more personas than just KiCad. It would not be the kind of thing where you can open Cadence and save it as KiCad. I'm not as interested in that. It's more like being something that takes on that persona, Circuity taking on that persona.
Thank you. I had a quick question about what it learns. So you've got 15 workspaces, for example, and you've got 15 designs in there. So when you're asking questions, is that per design, or has it learned all of your designs and so you can learn commonality? Thank you.
It's a great question. The real big answer is I don't know yet. What it does today per workspace, only knowledge is siloed off to that workspace. A slightly longer answer is one of the things that we have in Circuity that's not launched today, but we call them linked workspaces. So as you may recall, workspaces are basically Git repos. And so linked workspace is the ability to have one workspace that links in the content from another. And if you think about it from Git terms, it's a submodule, a Git submodule. And that's how we get to shared libraries, being able to have a Git repo of libraries that you're referencing in. And at that point, there's question marks for us that we haven't answered yet, and we'd love to hear from y'all about like, okay, so can the AI see the linked workspaces? Is that okay? Who gives permission for that? If you're using design blocks, which we don't yet support, but if you're using design blocks from another workspace, can the AI see those? Can it not see those? What does it mean to not see those? So lots of questions for us. Unfortunately, I have more questions than answers on that yet, but that's the kind of maybe giving you vibes about how early we are. We have one down in the front too.
So one of the possible uses, I think, for this is there are lots of companies that build microprocessors, widgets, et cetera, and publish reference designs. It strikes me that, for instance, you go to Analog Devices and they've got hundreds or thousands of reference designs, and they'll give you Gerbers or they'll give you something, but there's no clean way to peruse the reference designs without installing some specific tool. So it strikes me that marketing your public-facing web thing to corporations that can provide their design, reference designs on your platform that are easily pullable off into KiCad or maybe other CAD translators into other CAD systems. I mean, I would probably, if you had that as here are a bunch of companies presenting their reference designs on our platform, I might actually use that for my company. So that's just a marketing idea for you.
You're hired. Go on in the back.
Sorry. So I had a question regarding the AI upload. You mentioned there were two separate platforms supported. I've used occasionally these tools to try and understand. I'm not an EE myself, trying to understand things that I wanted to understand. I felt it's somewhat tedious describing these things in verbiage. Am I correct in assuming that it uploads an image or a screenshot of the? Is that how it transfers the information? And then, if it's being uploaded as an entire image, is that in fact complete context? Because then you have the additional component properties, other sorts of information such as layout properties that might not be present on the schematic itself. How are you dealing with that kind of multifaceted feature of the design, both in terms of IP protection and the format that you're using to get the responses?
Walter, you're making me give away my secrets on a live stream. So great question. We do not give it an image. So we provide the AI with essentially, you could think of it as, it's not this, but you could think of it as like CSV data. So some of the magic behind like prompt engineering for AI is trying to get data into a format that you can hand to the AI and then trying to tell the AI what that format is. So it's pretty cool. I mean, it's sort of interesting. You're describing, we spend so much time as software engineers thinking about APIs and how do we call functions, and then here I feel like I'm basically describing to somebody in English how to call my function or what my data is. So we provided the data in a format that we cooked up, that we've iterated on to figure out is consumable by the AI. But the AI doesn't know what it is, and so then we have to tell it. We have to say, oh, column 1 of the CSV type data is this, and column 2 is this, and then there's a net list. And as a human reading that, it's in English, but it's like a megabyte of that. It makes no sense. But to an AI, it loves it. So in terms of IP protection, though, we are feeding your data into Google. Now, they promise it's private and SSL and blah, 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 but this is where we have the no button.
I think I'm next. I'm interested in your comments about you needed to go through an analysis process where you derived the sort of conceptual structure of KiCad, and part of that was leading to a superset of the data model and so forth. How much effort was that? Was it easy to derive? And how did you capture that? And could that be fed back into the KiCad project in some way as an alternative aspect of documentation?
Oh, I don't think they want our stuff. But we reverse engineered it. So thank you to whoever did the big transition at 6 into kind of Con's S expression stuff, like, so much more rational than spaces. Thank you, Walter. So much more rational than spaces and tabs and whatever. So that made it really easy for us to generate a ton of conformance data that we do partially manually, partially automated, and then we're able to understand, kind of reverse engineer what is happening, because our deal has been to not use the source or look at the source to understand what's going on. And it's actually been really helpful, I think, for us, because we're able to kind of try to look at intent and not necessarily the long 36-year journey of why things are the way they are, but more, okay, what is it today and how does it work and why does it do that? And so, yeah, I'm not sure that would be helpful back into documentation. We also look at the documentation, which is, on the Creative Commons, so that's been amazing. I know we're kind of probably running close on time here, right?
Maybe one more question. If you mentioned that you can import multiple versions and then export to that same version, can you? This is kind of a question for the internet audience, because I know someone's going to ask this. Can you open a KiCad 9 file and save it as a KiCad 6 file?
By accident right now, yes. In theory, yes. Of course.
That just multiplied your signups by...
Yeah. So the challenge there, as many of us know who have either written things that are working with the KiCad format, or I'm assuming the dev team, is, there just are a lot of things that have been done. I'm only looking from the outside, but to rationalize things, to make things make more sense, to put content in the right places. Like we used to have, kind of sheet instance references kind of at the end of a schematic file, and now they're embedded. And these things are you just see them, and it just, for somebody who's been looking at KiCad file formats for quite some time, I had a viewer program I did a while ago called Erie. It's just it's like a warm hug. But then, you have to support 6 still. So writing back and forth, some of that stuff is lossless, but the introduction of Bezier's, as I think Wayne mentioned, that was supported long before you could create it. But there are things like that just aren't supported in certain versions. So we become lossy. But that's, if people tell us that's something that they're excited about, I would love to put effort into it.
Okay, thank you very much.
All right, thank you. And special thank you to the organizers, Seth, and thank you, Wayne.